In this video, we're going to be talking about graphing absolute value and graphing absolute value equations and graphing absolute value inequalities. So what we are going to do here is I'm going to give you a few pointers and some notes to take so you know exactly what's going to happen. Now, these notes are going to be used for several graphs you do in Algebra 2. So you might want to write this stuff down, okay? So anytime you're graphing absolute values, specifically the ones we're going to do today, they're always written in this form. Y equals A absolute value X minus H absolute value plus K. Okay? Your A is responsible for one thing. Your H, including the sign, is responsible for something else. And then your K, including the sign, is responsible for your final thing, okay? So when we look at A, let's talk about A. We talk about A here, sorry. A does a couple of things. A determines, number one, your opening. If it's going to open up or down. Again, this is going to be the same information used when we get to quadratics and stuff, so this is good information to know. And A also determines if it's going to be a vertical stretch or a vertical compression. Okay? Excuse me. When it's a vertical stretch, that means that your graph gets elongated and you end up with a vertical stretch when your A is a whole number bigger than 1. Sorry about these allergies, but hey, we're going to deal with it. And then the vertical compression, when A is typically a fraction and it's less than 1. So when you talk about your parent graph, which we'll get in a minute, let's say this is your parent graph, a vertical stretch makes it more narrow in the middle like that, and a vertical compression makes it more wide like that, okay? And the example that I use in class, imagine if you had a balloon and you drew a face on it. If I had this balloon and I drew a face on it, if I were to take the top right here and the bottom and stretch it, the face would look like that. If I take that same balloon and I squeeze the top and the bottom, the face will get more flat. So this is a vertical stretch. This is a vertical compression. All right, enough of that. Whoops, meant to erase that, sorry. All right, now, let's talk about H. H is whatever, so this is H. H determines your horizontal shift. Whatever's right here, you typically do the opposite. But a safer thing to say is your H is always whatever makes this whole thing 0. What makes that 0? And we're going to see what that means in a few moments. Okay? So you typically, if there's nothing in front of this X right here, if there's nothing there, you just do the opposite, whatever is in there. But if there's a number in there, which you're going to run into, we got to figure out what makes that 0. And finally, for K, K is the easy one. And then K is your vertical shift. up and down. And then you're going to end up doing whatever it says. So if it says +2, we go up 2. If it says -2, we go down 2. Okay? Your vertex, which is really, really important, is always at H, comma, K. So in other words, whatever is opposite of that H, or whatever made that 0, and then whatever your K was. All right. We're going to answer some of that in a minute. I do want to go ahead and cover absolute value and the inequalities. Really quick, I'm going to remind you guys, for those that watched my video or had me last year when we did Algebra 1, I gave you this table that looked like this. A was above, B is below, D is dotted, S is solid, and we did one of these. Well, guess what? That table still applies, because when we graph our absolute values, you're going to end up going to the vertex, and we're going to be either shading above or below when we get to those. Let's jump right into now. So now that you have the fundamentals, let's jump into what we're going to be doing. Some of these are easy to graph, and some of these are a little bit more complicating. All right, so let's get to it. All right, so we have our first set of equations here. Whenever you start, you want to identify your A, H, and K. On this one, you got to identify A, my H, and my K. My A comes from right here. There's nothing there. So when there's nothing there, it's not 0, it's 1. My H is going to be opposite of this, so +4. And my K is going to be the same as that, -1, which means my vertex is at 4, -1. Let's go and plot that first. 4, -1, right there. Now, your A is going to tell you your pattern. Your pattern is always over 1, up 1, because of your parent function. And really quick, your parent function and when you end up graphing this, 1, 2, 3, 1, 2, 3, 1, 2, 3. You always got 1 in the middle. You got to point at 1, 1, 2, 2, 3, 3, 1, -1, -1, -2, -2, -3, -3. So that's what we call the parent function. All the graphs will look similar to what you see here. Okay? So because my A is 1, I can go over 1, up 1, over 1, up 1. And I can do the same thing on the left, and there's my graph. That simple. Okay? Let's go to the next one. Now, I will say that some of these coming up, we are going to have to create a table. But these right here are simple. So let's go identify our A, identify H, and identify K. So my A here, there's a negative out there. So my A here is -1. And because my A is -1, that automatically means it's going to open down. So it's going to make an upside down V. Okay? My H, what's inside of there with the X? What can make that 0? The only thing that can make that 0 is 0, because the H is missing. And then my K is -1. So I got my vertex is at 0, -1, 0, -1. That's this point. And my pattern is still 1, but because it's negative, I have to go down like so. And yes, those are perfectly straight lines, even if they don't look like it. All right, here we go. Let's do number 3. Okay, now we got a little bit of razzle dazzle. I got to identify A, H, and K. This time, my A is -3. My H is what makes this 0. Well, that X would have to be -3 to make that that absolute value 0. And then K is what's back here, -2. So my vertex is at -3, -2. Sorry, I lied. K is +2. JK, LOL. So that's going to be at +2. So -3, +2. And because my A is -3, we're going to open down. But because my A is -3, we're still going to go to the right one. But instead of going down 1, we're going to go down 3 because A is 3. Over 1, down 1, 2, 3. Over 1, down 1, 2, 3. And same thing on the other side. Over 1, down 3. Over 1, down 3. Let me show you how to draw some perfectly straight lines. Yes, that is so good. Beautiful. Okay? All right. What I want you to do is pause the video right now and try this one and see what you get. All right, pause it right now. All right, now that you've had the time to try it, let's see if you got it right. First, you should have identified your A, H, and K. My A is +3. My H is 1, or is it -1? If you said -1, you are right, because it's what makes that 0. And my K is going to be -3 here, because this -1 will make that 0, and my K just is the same as that. So my vertex is at -1, -3. Let's plot that point. And because it's positive, I'm going to go over 1 up how many? What you think? If you said over 1 up 3 because A is 3, that is right. Over 1 up 1, 2, 3. Over 1 up 1, 2, 3. Over 1 up 1, 2, 3 again. Over 1 up 1, 2, 3 again. And this is that one. All right, moving along. These two, what happens when there's no number in the back? A, H, K. So my A is 2. My H is -4. What's back there? If nothing is back there, what number represents nothing? 0. So my vertex is at -4, 0, which is here. And then, because my A is 2, I go over 1 up how many? If you said 2, you're right, because A is 2. Over 1 up 2, over 1 up 2. Left, over 1 up 2 on the other side, over 1 up 2 on the other side. Because these are always going to be, absolute value is always symmetrical. Although sometimes in the question we get to later, they don't seem like it, but they really are once you actually draw the lines. All right, let's take a look at number 6. We're almost through all of these. And then we're going to transform some of these questions that we just did. We're going to make them into absolute values so you don't have to graph them again. Only thing we're going to adjust is shading. Okay, so my A here is 3. H is 0 because there's nothing in there with the X. And my K is 4. So where's that vertex at? 0, 4. Sorry, I lied. -4. JK, LOL again. And because my A is 3, I'm going to go over 1 up how many? You should have said 3. So I'm going to go over 1 up 3. Do it again. Over 1 up over 1, up 3. And then over 1, up 3. That's this one. Over 1, up 3 again. That's that one. And I'm going to connect the dots. Now, what happens when I start getting, how many I got left? Oh, just 2. What happens when I start getting stuff on the inside and the outside and things start getting crazy? If all else fails, make a table. Okay? So we're going to do number 7, and we're going to make a table. Although we don't really have to, but we're going to make a table on these last 2 so you know how to make a table. Okay? So, A, H, K. So, what is my A? -2. What is my H? Oh, wait a minute. We can't just say opposite of -2 is +2. Remember, our H is whatever makes a 0. So we got to figure out what's going to make that 0. So I'm going to solve it right here. I'm going to add 2 to both sides. -2x equals 2. Divide both sides by -2. That means x equals -1. So our h is -1. And there's nothing back here, which means that our k is 0. Which means that my vertex is at -1, 0. -1, 0 is here. Now we need to make a table to get some more points. So we're going to do x, y, 1, 2, 3, 4. Let's do 5. 1, 2, 3, 4, 5. We want to put our vertex in the middle. -1, 0. Now you want to pick 2 points to the left, the nearest 2 whole numbers to the left of that -1. So that'll be -2 and -3 right there. And then you want to pick the nearest 2 whole numbers to the right, which is 0 and 1. Okay? Now, I'm going to show my work over here under number 8, but I'm going to erase them as I go. So make sure you leave yourself enough space to show all your work, because I'm going to run out of space, so I'm going to have to erase as I go, okay? So we're going to plug in -3 first into where this x is at. So I got y equals -2, absolute value, -2 times -3 minus 2. And then I have another absolute value bar. Okay? -2 times -3 is positive 6. That positive 6 minus 2 is 4. And then -2, and then the absolute value of 4 is 4 still. So -2 times 4 is -8. So this is going to be -8. So I got to go to -3, -8, which will be up this way somewhere, right? Okay. So I'm about to erase this. You can go back and pause it if you need to. All right, now for the next number, I gotta plug in this -2 where this x is at, right there. So we're gonna do the same thing that we just did. -2, absolute value, -2 times that -2. There's a whole bunch of -2s on this one. Minus 2. Wow. All right. -2. -2 times -2 is a positive 4. Positive 4 minus 2 is still just 2. Now, what's the absolute value of positive 2? Still positive 2. But once we acknowledge that absolute value part, we can change that to parentheses. And negative 2 times 2 is negative 4. So the next one is negative 2, negative 4. Oops, hold on, I just made a mistake. Negative 2, negative 4. Just kidding. On this last one where I said negative 8 and I said it was up this way, I was testing you, see if you were paying attention. Hopefully you caught that, because I really was just testing you, because negative 8 is really like way down this way. And if you didn't catch that, that means you weren't paying attention. Yeah, that's my story and I'm sticking to it. All right. So we're going to keep going. Now, let's do the next one. We're going to plug in 0, because that's our next number we have to do. We're going to plug in 0 right there. So y equals negative 2, absolute value of negative 2 times 0 minus 2, close absolute value. And then, so negative 2 times 2 is going to be 0. 0 minus 2 is negative 2. And then what's the absolute value of negative 2? That's back to positive 2. And we end up with positive 4. Negative 4. Negative 2 times positive 2 is negative 4. I was testing you again. So my next point is at 0, negative 4. And then my final one, I'll do in green. I need to plug in that 1 right here. And what I'm going to do here is I'm just going to erase that, because I'm going to erase this, because that stuff doesn't change. So I'm going to plug in the negative, I'm sorry, I'm going to plug in 1 right here. Negative 2 times 1 is negative 2. Negative 2 minus 2 is negative 4. What's the absolute value of negative 4? Positive 4. Negative 2 times a positive 4 is negative 8. And that would have ended up this way-ish. And then when I actually graph it, it'll look like that one. Okay? So I'm going to erase this one. Now, although this wasn't part of the original equation, I'm going to add something to this one. I'm going to put plus 1 at the back. Really make us work here, okay? So we got to first I figure out our A, H, and K, and then because we got to get the vertex, and then we got to create a table. Oh, okay, here we go. A, H, K. A is the easy one, negative 3. K is the easy one, positive 1. H, not the easy one so much, because I still got to figure out what makes that 0. So 3x plus 2 equals 0, minus 2 minus 2. 3x equals negative 2 divided by 3. X equals negative 2/3. Ugh. That point is not nice. I'm about to erase this because we're going to need some space to do some of our math. So I'm going to erase this because we don't need that. All right, so now that I know my vertex is at negative 2/3, comma 1, Negative 2/3 falls in between 0 and 1 because it's a fraction. And then on the 1. So it's going to be about like right here. Not quite on the lines. And when this happens, your graph looks a little bit off-sided because of the dots. But once you draw your lines, it kind of looks more balanced. So X, Y, 1, 2, 3, 4, 5. We want to put our vertex in the middle. And then we want to find the points of the whole numbers to the left, which is going to be -1 and -2. And then we want to find the whole numbers to the right, which is 0 and 1. Okay, let's go ahead and plug these in, see what we get. But we got one extra step on this one than we did on the last one. All right, so what I'm going to do is I'm going to write this down. Y equals, excuse me again, -3 times the absolute value of 3. We're going to plug in something for x, plus 2, and then we're going to add 1 at the end. So we're going to plug in this -2 first, because we're doing this one now. So I got to do 3 times -2 is -6. -6 plus 2 is going to be, -6 plus 2 is -4. So we're going to add that to this next step. Okay. What's the absolute value of 4? +4. Oops. And once we change that to a +4, we're going to change that to parentheses because we've acknowledged that 4 was changed, plus 1. And then we got -3 times 4 is going to be -12, plus 1 is -11. And we can't fit that on our graph. So we keep moving along. And I'm only going to erase certain parts because certain parts we're going to need again. Like we're going to need that absolute value bar. We're going to need this answer again. And then this is going to change because that plus 1 is constant. And then this is going to change. Now you can write everything out again, but again, I'm trying to save time and save space. So now I'm about to plug in the -1. I'm going to put -1 right here. 3 times -1 is -3. -3 plus 2 is a -1. On the next line, I got -3. Oh, change that. Sorry. What's the absolute value of -1? +1. Now I'm going to do -3 times 1 is -3. And then I got that plus 1. That was just hanging out. -3 plus 1 is -2. So my next point is negative. So I got -1, -2. Okay. Again, you can erase and write all these steps over. But for the sake of space and time, because I know that plus 1 at the back is never going to change. Only thing that's changing is my X stuff. All right, next one. We're going to go ahead and plug in 0. I like zeros because that makes my multiplication easy. 3 times 0 is 0 plus 2 is 2. Absolute value of 2 is 2. I need to multiply that times that -3, and I'm going to get a -6. -6 plus 1, -5. So my point is 0, -5. Now, and then that 1, we can plug in the 1 just to get the number there. So let's plug in the 1 to get our final number, even though it's going to be off of our graph. Plug in 1, and let's use this pinkish color. And put a 1 here. 3 times 1 is 3, plus 2 is 5. Absolute value of 5 is still 5. Negative 3 times 5 is negative 15. Plus 1, negative 14. Which won't fit on our graph. Now, I think I have, if I remember right, I have a ruler. And let me see if I can do this. If I connect my line to the points I just made, let's see if this works. Kind of working. So although my points looked a little bit weird, my graphing was the same, okay? And it's still balanced out. All right, now let's jump into some absolute value. I'm gonna do this real quick and simple. I'm gonna use the same graphs that we just did, but I'm gonna make some adjustments. What if my graph said, instead of saying, hold on. I'm trying to do this. Okay. What if it said y is less than or equal to absolute value of x minus 4 minus 1? Now, because this, I'm sorry, this is greater than. Because it's greater than, you go to your vertex and shade above, which means you're going to shade inside the V. When you're graphing absolute value, you're either going to graph inside the V or everything outside the V. It's one or the other. You never have both, okay? Let's say on this other one, on number 2, what if it said y is greater than negative absolute value of x minus 1? A couple things change. Number 1, because it doesn't have the equal to sign. Oops. My line is dotted. That changes. And because this says greater than, go to your vertex, shade up. Your shade up happens to be outside the V now. So that's this stuff. Okay. What happens if, what if this was negative, and what if this was y is less than or equal to negative 3 absolute value x plus 3 absolute value plus 2. My line is still solid because of this, but that says less than. Go to my vertex, shade below. Oh, that happens to be inside the V, so that's this one. I did 2 greater than. Okay, now what happens if on this one it said y is less than 3 absolute value x plus 1 absolute value minus 3. Again, my dots, my points don't change. Just my type of line does. Because there's no equal to sign, it becomes dotted. And this says less than. Go to your vertex, shade below, and this happens to be this part. It's the outside. Okay, that's the gist of graphing inequalities, equations. Absolute value equations and absolute value inequalities. Hopefully this video helped. If you need to watch it again, fast forward to certain parts, rewind certain parts, help yourself. If you have any questions, come see me in class. Have a good one.